Okay, good morning, everyone. Thank you, the organizer and the coordinator of this project, OMBS South, for the invitation. I'm glad to come back to Polytechnic after some years. My name is Daniele La Rosa. I come from the Department of Civil Engineering and Architecture of the University of Catania in local South. And I am working in a lab, which is called LAPTA, which stands for Laboratorio per la progettazione del territorio e dell'ambiente, which in English is something like laboratory for the design of the territory and the environment. And we are working on different fields related to sustainable planning, both at urban and landscape scale. And in the last years, we are specifically working in the field of ecosystem services and nature-based solutions, of course, and with some applied research that we try to transfer to real planning processes, so to planning processes of municipalities or regions. So this presentation is collecting some works and research that we have done in the last year, also with some colleagues who are working in Chile, for example. So that's why I will present some results of this kind of research, and will be about different types of urban simulation related to climate regulation. So this is the outline of the presentation. It's quite straightforward. Since these researches are about climate regulation, I will very briefly introduce which are the mechanisms beyond the cooling effect of nature-based solution. And then I will split the presentation into subparts. One is dealing with some urban simulation which use nature-based solutions, and more specifically urban greenery, trees, for cool down the indoor environment of the residential, but not only residential houses and districts. And the second subpart will be about some simulation to understand which is the potential of nature-based solution and urban greenery to improve the outdoor thermal comfort. That, as you can imagine, in some specific climate condition, like I can say everywhere in Italy, for example, but in many other regions of the world, is some very important issue to be addressed by planning. And this second subpart will also, the result coming from this simulation will be used also to propose some planning criteria to understand how we can better plan and design the components of nature-based solution, the components of the urban greenery, to increase the potential of thermal comfort of our cities. Okay, that's it. So I will not spend too much time for this. You can actually deep on these topics almost everywhere, because there is a very wide literature about this. So the basic mechanism for that the nature-based solution, and more specifically trees and components of the green infrastructure, can use to cool down the environment are three. The first one is the more relevant and more impacting one, is the direct shading of soil of the sun, or direct shading of solar heat on windows, walls, roof, and of course also the public spaces that we have in cities. The second one is the wind breaking effects, that is more useful for specific climates. And the third one is the evapotranspiration processes. So I go from the less relevant to the most relevant. So this is the wind breaking effect of tree, which is, as I was saying, it's more important in to slow down the wind, of course, close to the buildings, and to reduce the convective heat losses and infiltration rates that is due, of course, by the effect of the winds on the buildings, for example. And this is a very important effect, specifically in windy, cold, and frequently overcast sites. So where you don't have much solar gain, and you have to, of course, to keep as much as possible the heat that you can produce in your homes with your conditioning. And there are, of course, some best practice, some management, design rules that we can use, like to differentiate the components of the green in different structures, so to maximize the potential effect of trees to act as an obstacle to the winds, and to use different species, etc., and to try to have enough density of the canopy of the green structure that you can use. A second effect is evapotranspiration effects. This is processes. This, of course, a very well known and very well studied process. This is what happens when the vegetation breathes, actually. So it's the reduction in the dry bulb temperature due to evapotranspiration, as we can define it as a loss of water from the plant, from the vegetation, as a vapor into the atmosphere. In terms of effects that we can actually measure is a bit less important than the wind breaking and then to the direct shading, but still it's something very important that we can actually feel, as you probably, of course, know, if we go around our city very close to some vegetation structures. The third one is the shading effect, which is the one that we have studied a bit more in detail, because it's the more impacting, something we can actually measure very well. And the shading effects, so depends on different variables and parameters, like, of course, the tree species, the distance of trees and vegetation from the buildings, the actual shape and orientation of the buildings, and of course, the climate, the overall climate conditions of the places where we are working. And so all these variables are what the components of the structure of an urban morphology, which is a concept that many of you are probably aware of, which is involved, of course, a different relationship between all the elements of the urban environment. So streets, plots, vegetation, density of the vegetation, type of trees, density of the open spaces, etc. And all these features, of course, have a very important effects on how we can actually design and which will be the benefits that the green infrastructure and the nature-based solution can provide to urban environment. Okay, now I show you some example of these researches that we have done in Italy and also in other cities in outside Italy. So the first example are located in South Italy, where, as you can imagine, we have some let me say everywhere in Italy, but especially in summer of South Italian regions. These the Italian effect and the negative consequences of a very long period of heat is more tangible, and so it's a primary issue that we can try to address. And so these examples are located in the metropolitan area of Catania, which is the place where we are working, of course, and which is a very compact region with generally a very a lack of green spaces that can be used by people, a general low energy efficient of the built environment of the both residential and other types of buildings stock. So this research was gradually growing from some other researches done by colleagues in University of La Sapienza in Rome. And so we started with this model, which was developed by these colleagues, and that actually try to measure the effects, the positive effect on reduction of the energy demand of the buildings, thanks to the location of trees all around the building. So it was very interesting in its simplicity, because these guys actually measured in simulated, actually not measured, simulated the positive reduction of energy demand, putting single trees all around the building. So they started with one building, one tree, then they had the second tree, then they had the third tree, etc. So they come up with this kind of different configuration of shading potential of trees. So we started with these results, and we sorry, this is very important. This is absolutely an abstract example, an abstract environment, because this is a building, it's a cube, which is actually shaded by trees all around it. But what we did is to try to use this model in a real world configuration. So these are very traditional residential complex, made with building with, of course, as you can see, different shapes, but I will come back to this in a few minutes. And what we did is actually use this model to simulate the positive effect in terms of energy reduction, so in terms of energy saving, if the building is shaded by the trees. What we got was these results. Of course, the more trees you use, the better reduction you will get. But what is interesting is that even if you use a single line of trees shading for example, the east aspect of one building, you can get up to 20% of reduction of energy demands. Of course, this energy demand, sorry, I didn't mention, is about summer conditioning. So it's what we can save if we shade the building and not use too much the air condition, of course. And this range goes up to almost 50% if the buildings is almost totally surrounded by lines of trees. Starting with this a bit, rough, maybe a bit simplistic, we try to have a better view on the actual configuration of buildings and spaces where you can plant the trees, because it's not automatic that you have some room, some space beside the buildings where you can plant the trees, of course. So we want to have a look to the actual, more close to reality conditions, and also what we again in the metropolitan area of our city of Catania. And what we did also to simulate the impact of different type of trees, different species, using typical species that you can find in the Mediterranean climate. And so these are examples: the pinus, the platanus, and which is the third one, sorry, is the Ficus benjamini, of course, which is very typical in our. And we also wanted to have a look to real shape of the buildings, and we considered the most typical ones, which is this shape that you can see here. And what we did is we simulated the different configuration of trees and buildings. So depending on the distance, the actual distance of the potential trees to the buildings, if the entire side of the buildings could have been shaded, or if just half or 1/3 could be shaded, because you don't have space all aside the building to where you can plant the trees. And these things actually turn out into different configuration that we have simulated thanks to this software which is called Transys. And we got this kind of very brief result that I'm of course summarizing here. We can get reducing of cooling energy up to 17% of reduction, Overall, the species like the Pinus, which has this kind of shape like an umbrella, if the Pinus is tall enough, will be able to act as a real umbrella in terms of shading. So this kind of species is actually performing better than the other. And of course, but this is also depending on the distance, and the overall, the best distance that you can use is between 5 and 8 meters. But this, of course, again, depends on the type of trees. This same approach we have also used it in 2 examples in Chile. So it's again Mediterranean climatic areas, and the objective was the same, to estimate the reduction of cooling energy that we need to cool down the residential buildings. So we have 2 different area. One is which are not far one from the other. One is Santiago, the capital, and one is Viña del Mar, which is not far from Santiago. It's close to the seaside, and it's a more Mediterranean type of climate, even if a bit cooler than our Mediterranean climate due to the influence of the ocean breeze. So we used the same model. We estimated the actual potential location of trees and what happened in terms of reduction of energy demand of these buildings if we plant some trees close by this nearby, sorry, to this building, to the residential buildings. Again, these 3 species were simulated. Different configuration was simulated, and what we get is, I mean, similar result. And again, no, sorry. What happens that depending on the dependence on the tree species was different, because in these cases, for example, only in Viña del Mar was the Pinus better performing than the other species, while in the other Chilean residential area, the best performance was given by the Ficus benjamina. And what is interesting in this kind of approach that what we would like to do in the future is to try to test some AI algorithm to increase the number of configuration, so that can be to obtain like a catalog of a database of potential energy saving performance that we can have according to the different type of different shape of the building, different type of the trees, different distance from the trees from the building, and like that we can try to figure out without planting which will be the potential benefits that we can get in planting this tree according to this different configuration and the different variables. Okay, I think I'm okay. So this was the first part of the presentation, which is about indoor climate regulation. But then in parallel, we also working on outdoor climate comfort, as I was mentioning at the beginning. And we have tested the use of this kind of model, which is, I don't know if any of you is familiar or heard about this. It's called UMEP. UMEP stands for Urban Multiscale Environmental Predictor. It's actually it's a climate tool, totally open access, not only free but open access, and that has a very strong pro, especially for us that are dealing with especially explicit representation of our cities. The most important feature is this model produce maps. It's a specially explicit model, as the previous one that I showed to you weren't. Were just models that gives you numbers, but these are actually producing maps, and I'll show you in a second. And this is quite useful because you can actually simulate the impact on outdoor thermal comfort of changing the configuration of our cities. Okay, it's a very complex model, but not very complex to use, luckily. And we adjusted. I show you some results, some scenario which have been derived by this model, but just out of one module of this model, which is a bit more complex than what I will show to you. And what very interesting again is that this model is actually a plugin of QGIS, so it can be very easily can be downloaded freely, used freely, and because it's open access again, and it's integrated in GIS, so you can use your data, your GIS data directly in the QGIS without having to export or import anything, almost anything. Okay, maybe I can skip this because it's a bit late. Okay, this is how this module that we is dealing with the outdoor comfort is working. There are some layers that can be inputted in the model, which are not so many actually. There are some, of course, basic condition of the climate that you have to input to the model, because the model has to know where you are working, and you have some land use, land cover information, which is of course absolutely essential, and that's actually it. There's no now you need some 3D models of your area, because 3D helps the model to understand how tall are the buildings, and so which is the impact on buildings, and also the age of the trees in producing these kind of outputs. These are the output. I will show you some results. So these are this model produces this output of this parameter, which is called mean radiant temperature, which is a thermodynamic parameter. I don't go into detail, but if you're interested, of course, you can ask whenever you want some more details. It's a proxy of it's a variable that you use to measure the thermal comfort that someone has if he moves around or she moves around the city. So it depends on what this guy is doing, the temperature, the external temperature, the wind speed, the humidity, etc. There are some parameters that are influencing if I feel good, if I not feel good, if I feel hot, or if I feel cold. Okay, some results of this in our metropolitan area. This is not in Catania city, but it's in the biggest municipality that we have after Catania. It's called Acireale, which is 60,000 inhabitants, so it's a medium city. And we're working very close to the historical center, but still here you can see there are some room for green. What we have done is to, of course, simulate the current state of this mean radiant temperature, this parameter, identify the places where you have some thermic stress for people, of course, going in the city, and in this area in these areas where the stress is higher, we have tried to develop some scenario of greening, urban greening, considering some localization criteria. So I would like to underline that these are made with very high resolution data. So this is not Corinne, of course, land cover. This is not regional land use data, which is not enough to grasp this kind of behavior, this kind of differences that you can get in the city. So these are actually land use, land cover data that has been derived by some official sources like regional land use map, but then refined at a scale which I would say is around 1 to 2000. So it's very high resolution scenario. This is why you can see that in the model we have the 8 of each, maybe almost each trees or each rows of trees as a specific 8 which is assigned to it. So it's quite specific, high resolution information that is needed to get this kind of results. So we simulated some scenario, also understanding where we can actually put the trees. It's not the same if you put in private spaces or public spaces, because the way you can acquire these areas are totally different. And okay, what we get is some results out of this. Also, we played a bit with the amount of trees that we can implement, and we got these results. The result that we got is the impact of this nature-based solution, this urban greenery, on the outdoor thermal comfort, specifically on the mean radiant temperature, are visible, but are not dramatic, because they are very much concentrated just below the canopy, or just where you are planting the trees. So this means that there is a limited mass effect that you can measure, that you can simulate, sorry. And this, according to the model, it seems that you have to, concentrate your effort, your economic effort, to plant new trees, to implement new greenery, where you have the more people that can actually use and walk just below or aside these trees. This is a kind of specific feature, can be a bit a limitation of this model, because, for example, the evapotranspiration effects that I mentioned at the beginning is not taken into account by this model. And actually, this can be a bit a limitation. But it was nice to understand that, you have to plant you have to implement the greenery where there are people that can actually benefit from it. So these findings, okay, well, we also had a look to different type of species that we can use according to the previous other research that I showed you before, and we produce this kind of small scenarios, small plan for the municipality. Okay, very quickly, because I think I have 2 minutes. Okay, these results have also were useful to distill some criteria that we try to that would like to be as much as general as possible, so that can be transferable to almost any urban setting. This criteria has tried to address this kind of question: which type of greenery we can use to maximize the outdoor thermal comfort, where this greenery can be located, at what extent we need to implement this, and which kind of species we can use. According to this preliminary result, we can try to, but some of these criteria I've already anticipated to you. The models say that the trees, of course, and not other type of green elements, are the most performing. So the contribution of trees is absolutely fundamental, because they have the structure, the mass that is can be used to maximize this the shading effect. And other type of greenery, like shrubs or herbaceous vegetation, are less impactful in terms in a positive term, of course. So they can be considered, but maybe for other secondary purposes, like ecological heterogeneity, or some kind of ornamental purposes. Where we should locate and when we should plant this kind of trees, of course, in areas where we can maximize the benefits that these trees can provide to people, so public areas, of course. Sideways, absolutely fundamental, because in our cities we have plenty of sideways where there is no trees, and this is a very big issue in terms of costs and other type of problems. Of course, permeable soils, where available, should be prior options for the location. And on the other way, so of course, private areas and impervious soil are, of course, places where can be places with lower priority, because private areas are more difficult to acquire. You have to negotiate with the private owner. You have to find, as was mentioning before, some incentives or policies to deal with to convince people that it's good, or they can also provide benefits not just to the owners of the plot, but also to other people that can probably, for example, are walking just beside the trees which is planted in someone properties, etc. Yeah, and another thing is that if you implement the greenery as much as close to the buildings, you can have a double effect, because you can have an effect of cooling, partially cooling the building, at least the lower stories, the lower floors, and at the same time, if you have space enough, you can also provide shading to the people who are using that sideway. How much we can plan, of course, this is depending on how much money we have, of course, and also at least should be addressed at the most critical area of the urban environment. For example, there are some studies who suggest some threshold for this mean radiant temperature that should be, of course, decreased. Okay, then there are also some criteria for the use of the species, like it's better to have high density canopy, absolutely. If use deciduous or evergreen, depends on the climate. For example, in Mediterranean and hot climate, it's good to have evergreen, because it's not a big issue if there is some shading out of the trees even in winter, because winter are not so dramatic. So, but this can be different if you are looking at continental climate, for example. Fast growing, absolutely fundamental. We need fast growing trees so that you can you can plant when they are younger, so they are also cheaper, and they can actually grow as fast as possible to reach their adult stage. Also, some issue of ecological heterogeneity should be pursued. But for example, in our belief, it's the need of using autochthonous species is probably not so, it's not a priority in terms of all the other criteria that we are listing here for the choice of the species, because our cities the vegetation in our cities are very often made of alloctonous species. Look at the eucalyptus use or in South Italy, for example, in all Italy, let's say. Okay, that's it. There's some conclusion. And different factors influence the performance of nature-based solution in reducing thermal stress and increasing the energy efficiency of the residential stock. We have seen by this simulation that even little amount of green located close to the building and using the correct species can have a good reduction in terms of energy demand of the building. Looking at the outdoor thermal comfort, we have seen that we need this kind of model which are spatially explicit to understand where we can change the current configuration of cities and which will be the effect of our scenarios. And of course, that to maximize the benefit, the economic resources, this is something maybe can be a bit straightforward, but if you then look at the maps, you will be a bit more convinced. To maximize the benefits, the economic resources should be concentrated for places that are used daily. So, for example, if there are sideways which are located in more, peripheral or less central, less used part of the city, probably if you have to deal with the constraint of resources, you have to probably skip at the first stage this kind of places. That's it. I would like just to mention about this cooperation project, a project that we are working in. We are working since the 2021, sorry. which is called Urgent. It's a capacity building project. It's Erasmus Plus capacity building project in the field of higher education, which is dealing with nature-based solution and green blue infrastructure with colleagues of India and Mongolia University. So we have, in this project, we have tried to, modify a bit and update the current offer of the university that were involved in the project to include this kind of topics, like, again, blue and green infrastructure and nature-based solution in their higher education system. So we have made new courses. We've been there to teach some of these courses. We're still working with them. We are co-supervising students. So this is a nice way to try to apply this kind of topics in the field of international cooperation. Thank you very much.